Today we are going to talk about recursions. So the goal is I can create and use recursion equations to calculate values. So similar to what we were doing with series and sequences, the format just looks a little bit different. Okay, we'll get on the right screen here. So this is the definition of recursion, the process of defining a problem into a simpler version of itself. So we're going to start by just talking about the notation. So a sub 1 is the first term, just like in series and sequences. A sub n, no surprise there, is the final term. And anytime you have a sub n minus 1, it just means the previous term. So those should look pretty familiar from series and sequences. This is the way it works with recursion equations. They give us the first term in the list, which is 10, and then I just do what it says. I'm going to find the final term by taking any previous term, and by final I mean the next term. Let's just say the next term. The next term is always the term before it plus 6. So if we have 10, I can find my next term by adding 6. I can find my next term, 16 plus 6, 22 plus 6, 28 plus 6. Okay? Let's look at multiplication version. So again, it is the first 5 terms. So the first term is 55. The next term we're going to find by doing what it says. We're going to take 55, we're going to multiply it by 1.05, and then we're going to subtract 9. When we do that, we get 48.75. So that's our next term. Okay? My third term is going to be 48.75. I'm going to multiply it by 1.05, and I'm going to subtract 9. And I should get 42.1875. Okay, we continue on. 42.1875, multiply by 1.05, subtract 9, and we get 32.297. And we continue on. So 32.297. Do it one more time, we get 28.06. And I guess we could decide to round some of these to the nearest 10th or the nearest 100th if we really wanted to. All right, now we're going to look at a pattern and come up with an equation. So looking at the list, we can see our first term is -3. Well, what's happening in the pattern? So we want to decide if we're adding or subtracting or multiplying. Well, in this case, it looks like it keeps going down by 5s. So our equation is going to be the next term is always the previous term minus 5. Okay, so when we do a recursion equations, we need to list the first term and then what's happening in the pattern, basically. Given the recursion equation for the sequence, this time it doesn't look like we're adding or subtracting to get to the next number. We are multiplying. So remember, in order to find R, we always take any term and divide it by the previous term. Well, when we do it in this case, we get -0.75. We can test it out here too. Is -22.5 times -0.75, 16.875, and it does check out. So the pattern is we're always multiplying by -0.75. So again, we list our first term, and each term is the previous term times negative 0.75. Okay, using a graphing calculator to solve. So, if we're doing 19 terms, or especially if we're doing 80 terms, we don't really want to list 80 terms or even 19 terms. So this one is looking for the 19th term. Looking for 19th. So instead of doing that by hand, how could we do it using a calculator? So if you look in Schoology, these directions are also listed in Schoology just like this. So you might want to open that up and follow these instructions there as well. But what you're going to do is you're going to change your calculator to sequence mode. So you hit the mode key, choose sequence, and you hit enter. Then you're going to go to y equals, and you're going to pick the minimum. That's where you start counting the numbers in. Okay, so that's just whatever the minimum value is. So this is either going to be 0 or 1. Whenever we're talking about time, usually if we say something like 20 years from now, we're starting at time 0. A year from now would be 1. 2 years from now would be 2. So when we talk time, it's 0. But like in the last case, they said the first term is 19. What would the 20th term be? But with time, you want to think 0. Okay, use sub n, the pattern for the sequence, and then the minimum is the first number in the sequence. So in this case, we were looking for the 19th term, so once we enter all that, we can go to second graph, that's where our table is, and we can actually set the minimum. I guess this is the table setup. If you just go to the table and want to scroll down to 19, you can, but you can also go to save table set, like it says here, and then it pops right to the 19th term. And it's going to look like this. So basically our 19th term is 32. Okay, so let's look at a couple word problems and how we would set those up. So here it says the number of people that carpool to work has grown at a rate of 1.2% per year. If there are 2,500 people that carpool now, how many will there be 15 years from now? So this is another situation where we're talking time. So time starts at 0 because 0 days have gone by, 0 years have gone by. So we're going to say u sub 0 is 2,750, okay? And we're always going to find the next term, the next year, by taking the previous year and then multiplying by something. Well, we're looking at, it's growing at a rate of 1.2% per year. So the first thing we want to do is we want to change 1.2% to a decimal. So we'll move it over 2 spots. And then because we not only want to include the growth, we want to include the number of people from the year before, we have to add 1. Okay, so we're going to add 1. And this is to include previous amount. That is the people that were in the carpool the year before. So if I add 1 plus 1 plus 0.012, that's actually the multiplier. Okay, so you are going to put that in your calculator. And you're going to look for the 15th year. So you'd scroll down until year 15 had gone by, and it should say 3288.8. And since we can't have a fraction of a person, this is about 3,289 people. That carpool now. They're not in one carpool, they're carpooling now. Okay, let's just look at one last situation here. So here, it says you invest $400 into an account that pays 2.3% compounded monthly. Well, usually when you get interest, it is annual. So assume when you get an interest rate, it is annual interest rate. So if we want to know what it is monthly, we have to take 2.3% and we have to divide it by 12. We get 0.19167%. That is each month. Okay? We are going to change that to a decimal, so we'll move it over 2. So now we have 0.001, right? And 9167. We're going to add 1 to that, just like before, previous amount. And so we end up with a multiplier of 1.0019167. So if we're writing our equation, we want to say, okay, this is the first term, except our first term in this case is going to be a sub 0. I'm going to use u just because that's what we put in the calculator. U sub 0 is 400. And we're always going to find the next term. I keep wanting to use a. It doesn't really matter. It's just because in the calculator, we use u instead of a. We take the previous term and we multiply it by 1.0019167. Okay? So, we want to know what it would be worth after 2.5 years. Well, 2.5 years is equal to 2.5 times 30. I'm giving away the answer. 2.5 years times 12 months is equal to 30 months. Because remember that we were compounding it monthly. So 2.5 years, we're actually looking for 30 months. So that being said, we would scroll down to 30. And whatever matches up by 30, that's going to be your solution. We'll look at one more. And that is the same situation, except that in addition to the 2.3% interest, we are also deciding, hey, I'm going to throw in another $125 each month. So again, at 0 years, this is $400. Next year is the previous year times. So the interest rate is the same. So if it's 2.3% annually, if we're going to figure out monthly, it's the same number. So that's the exact same thing from before. This is the only difference, is now we're also going to add 125. Okay? And you continue with the same thing. All right, just one thing.